In the diagram, the vertices ABC of triangle ABC are concyclic, right? ABC concyclic. EB and EC are tangents to the circle at B and C respectively. T is a point on AB such that TE is parallel to AC. So you have your parallel lines. BC cuts TE in F. So BC cuts TE in F. Question. Prove that B1 is equals to T3. Prove that B1 is equals to T3. Point of departure when proving this is the fact that you have a tangent and a chord here. So you can start off by saying that B1 is equals to A 10 chord. So you have a tangent and a chord. So B1 is equals to A. B1 is equals to A. You have a 10 chord situation. So that's a very good point of departure. Tangent chord theorem. And after having done this, you need to prove, because you remember you are proving that B1 is equals to T3. Now you need to prove what T3 is equals to. You go back to your circle. T3 will also be equals to A according to what I see. Now the reason for that will be corresponding angles are equal, right? Corresponding angles are equal due to the fact that TE is parallel to AC. These are corresponding angles on these parallel lines. So that's your next step. After having recognized that, you have recognized the fact that A is equals to T3, and then your reason, so your statement is A is equals to 3. Your reason will be that corresponding angles. So you are done with that. So this is 1 mark, 1 mark, 1 mark, 1 mark. Therefore, B1 is indeed equals to T3. Question 1 done. Question 1 done. After having done this question 1, now we'll look at the second question in our list of questions. Now for the second question, we have to prove that TBEC is a cyclic quadrilateral. Now to prove that, we must then look at our tangents. So we have a tangent BE equals to tangent CE. Now these tangents are coming from the same point outside the circle. So tangents from the same point outside the circle. Nicely put would be, if you have two tangents that are drawn from the same point outside a circle, then they are equal in length. And then you will also have to look at the fact that you have B1. Let's go back to it. You have your B1. Your B1 automatically becomes equals to C3. Now we already know, according to the fact that these two are equal, that these 2 points are equal. So you can look at this triangle, for example, as an isosceles triangle, because you have this point and this point meeting at the tangents outside the circle, making this an isosceles triangle. Therefore, this point and this point are equal. Opposite sides are equal in an isosceles triangle. We go back. So B1 is equals to C3. And another thing that you should note is that B1, according to this, is equals to T3. So the fact that you've proven that B1 is equals to T3, it also goes to show that you are proving the quadrilateral, right? Now, lastly, you will have a statement stating that TBEC, right, is a quadrilateral. You will literally write that down. TBEC is a cyclic quadrilateral because of converse angles in the same segment, right? So you have your converse angles in the same segment, your converse angles in the same segment. Then, therefore, this makes it a cyclic quadrilateral. Literally, you would have had your mark allocated, 1 mark, 1 mark, 1 mark, 1 mark, also 1 mark for this. So you might even get 5 out of 4. I'm joking. But ultimately, you have a total